Okay, thank you. So I believe I have something like 45 minutes to go to complete my talk. So let me make sure that I stick on to the time, not to exceed that. I have so many slides, so sometimes I may skip some of them very quickly. It is not important that each one of you have to read the slides which I am going to show or understand every element of what I am going to speak. But what is more important is to have an idea about what I'm going to speak today, and it is possible for each one of you to collect information over the great information highway that you have, the internet, and much of those information which is there will be available to you in greater details. But what I want trying to convey is more important. So let me begin my talk on the space technology and Indian space program. See, when we talk about space program, it is, to me, it is always a very exciting journey. So when you talk about the exciting journey, you must realize that where you are. So I have marked here, you are here. The place which I marked is the solar system, the Earth moving around the sun in a huge, Milky Way galaxy. And the Milky Way galaxy is so huge that your mind or imagination cannot fathom the dimensions of it. The center of the galaxy itself is 26,000 light years, and a million light years away. Such a huge dimension it is. But if you go look beyond the Milky Way galaxy, what you see is again vast spaces covered by so many galaxies, which will look like the stars of the night sky. And it's our destiny to explore strange new worlds and seek places where nobody has ever gone, and seek new life and new civilizations to go boldly where no man has ever gone before. This is a statement made in Star Trek. No, it reminds of the such as insignificance of us, but also at the same time the significance of human being having an ability to look and understand the structure of the universe and make at least a small bit of progress generations after generation, and then create a deeper understanding of the universe. And this is our destiny to understand. And for that, there is only one technology that we have today, that is space technology. To go beyond the gravity field of Earth, go to the orbit and look at those stars and then find out deeper and deeper about it. Space technology is in front of us, and we must make use of it for furthering the knowledge of human beings. And the Indian space program started. We all know that is Vikram Sarabhai, the father of Indian space program. Started it during the early 1960s. As a visionary leader, he could play such an important role in bringing about this small start at that time, when everybody in India thought that it is not a very significant step for an underdeveloped country. But he realized that the space technology is one of the tools that we can use to solve problems of the common man. So while this whole program was built up, the benefits for common man was one of the themes that he created, and it continues to be the guiding spirit of our space program today. So we say the vision statement in Indian space program is to harness space technology to meet the developmental needs of the country while pursuing space science research and planetary exploration. So we not only do the work of what is needed for the common man in the ground level, but we also look at the future. I think it is important that we look at the future. So we look at science, we look at exploration, we also look at how to understand the nature of the universe deeper with whatever resources that we are able to spare from our national wealth. We should also not forget that the country can boast really about those work of great astronomers. I just want to talk about only two of them. Aryabhatta, who so many years back in AD 700, he could compute the speed of rotation or the period of rotation of planets around the sun. If you just compare the numbers of Aryabhatta with the modern value, you will be really surprised to see how accurately that he was able to estimate them. And these were later verified and estimated only in AD 1715. He could also explain the eclipses properly. I think this is something really wonderful thing that to happen in India's astronomical history. But we also know that all of this were lost at a period. But it is our responsibility to bring back those those brighter years of India's history. It is true of Bhaskaracharya, who was born during the 1114 to 1183 AD, who has written his important books of Siddhanta Siromani, Lilavati, Vijangita, Grahangita, Goladhyaya, and those are such books which talks about the planetary positions, eclipses, and many such measurements. For example, the Surya Samhita, which we say is one of the basic books on the astronomy that will influence the West. So he also brought out the idea that the objects fall on Earth due to the force of attraction of the Earth. The concept of gravity, though he wouldn't use that word called gravity at that point of time, much before Isaac Newton identified the gravity as an important force in the creation of the universe. So these were some of those great stars of our Indian space program who really started this the thought process in our history. Today, the Indian space program is a multifaceted activity. There are various dimensions of the Indian space program, starting with the space applications, which is the topmost element of the whole activity. How the space activity in the form of building rockets, satellites, and finally how those satellites are put to use, and that is what we call space applications. To do space applications, we need space infrastructure in the form of spacecrafts orbiting around the Earth. And to put the space satellites, we need the space transportation system, the rockets to take it to the space. To build the rockets and satellites, we need the capacity around it in the form of infrastructure, design capability, building capability, testing capability all across various ISRO centers. We also look at space commerce on how to bring about benefits of this activity in terms of financial gain, bringing industries to participate, and how to market our products. We also have another stream of activity today that is taking human beings to space and then build those capabilities in exploring the space around Earth and also other planets. I think these are the basic work or dimensions in the space program, but it continues to remain people-centric and application-driven throughout. Today, the organization is a very interesting structure compared to other departments or ministries where we directly report to Prime Minister, the Space Commission being the apex body of it, and the Department of Space under that. And the Indian Space Research Organization is an organization which is handling so much of activities in the form of ISRO centers, and Vikram Sarabhai Space Center, VSSC, is one of the centers where I am heading. There is a Liquid Propulsion Center. There is Satish Dhawan Space Center, which is a launch port. URSC, which is a satellite center. UR Rao Satellite Center, Space Application Center at Ahmedabad. NRSC, National Remote Sensing Center at Hyderabad. HSFC, Human Space Flight Center. We also have laboratories under Department of Space, the PRL, NARL, Northeastern SAC, SCL, IAST, and also the commercial wings, the Antrix, NSIL, and InSpace, and also other units of the ISRO centers, the IPRC, IASU, DECU, MCF, ISTRAC, LEOS, and IIRS, which is hosting this program today. So this is the structure of a multi-layered organization where the ISRO plays a very important role in liaising with all the stakeholders, including the Department of Space. Now, ISRO centers and units and the laboratories are spread across the various locations of this country. It has a starting at Ahmedabad, the PRL, and also at Tumba, and then slowly spreading across various units of various places across the country. And it is still further spreading in various forms by creating ISRO centers or ISRO activities in various educational institutions, also the outreach activities where for example, you know that Dehradun, we have the Indian Institute of Remote Sensing, and also the Chandigarh, we have the Semiconductor Laboratory, and the only launching port for the Satish Dhawan Space Center at the eastern coast of India. And we also have downrange stations at Port Blair, etc. So I'm not going to each of them. So these are the units and centers of ISRO. And more than this, we have so many industries, almost 500 industries doing ISRO-related tasks at various locations all across the country, who are suppliers, manufacturers, developers of various elements that goes into our space program. Let me quickly go through some of the accomplishments of Indian space program very quickly. In a summary sheet, I have put it like this. We had made till now 191 missions. Missions include launch vehicle missions, satellite missions. The satellite missions, almost 111 of them, consisting of remote sensing satellites, communication and navigation satellites, and also the science missions of Chandrayaan-1 Mars orbit astrosat. We have launched almost 342 satellites from other countries, 34 different countries, 12 student satellites, 2 re-entry missions, and some of the technology missions which are shown here, which includes the pad abort test, the crew module recovery, reusable launch vehicle, scramjet. So these are some of the missions that you have accomplished in terms of the, in a mission statement way, I can tell. And we have 3 launch vehicles currently in operations, the PSLV, the GSLV, and GSLV Mark III, and so many satellites. So I'll come to the satellites next. Right now we have 53 satellites in orbit, 17 of them for the communication, 25 of them for the observation, 24 of them. Then navigation, we have 8 of the satellites, and space science related Chandrayaan-2 Mars orbiter missions, astrosat currently in orbit. So this is the total number of satellites in orbit, and all of them are being serviced, maintained, operated 24/7 basis using our ground infrastructure, monitoring systems, and tracking and servicing network all across the country. Now, let me go a little more detail into the spacecrafts and space applications, which is the core of the training session today, but there will be much more deeper elements of the applications coming from various other speakers, that they are going to take the classes in subsequent days. So I won't spend much of the time on those elements, and I am not an expert in some of them area as well, because as already stated, you heard that I am a specialist in rockets, but of course I have an aptitude to understand the space applications. I am really inspired by the work done by the application people. So let me start with the space applications and satellites, which is the core of our assignments and work. And our satellite diversity is really, really wonderful one, and we have been successful in realizing various types of satellites, various bus we call. They are of different class in terms of communication. There is one type of satellites, this huge one, being almost up to 5 ton plus. We have navigation satellites, which is based on a certain remote sensing bus. The remote sensing satellite per se are of various bus structures, various arrangements, which looks at various observational platforms in optical and radar and other means. The structure of satellites when it go for interplanetary missions like Chandrayaan-1 and Mangalyaan are yet another class of satellites. There are small satellites which are built into small buses, which are now very compact electronics and compact systems, which will be able to realize satellites at much low weight. And even micro and nano satellites, which weighs in 20s, 2-digit numbers, they are also being developed, and especially for the student community, these type of satellites are being facilitated. So these are the array of various design diversity of satellites which suit different platform requirements and also launch requirements. If you look at the communication satellites, we essentially call them transponders. They are the type of elements on board the satellite which service sending the signal there and then sending it back to the various spots on the nation, thus enabling bidirectional communication, relaying of communication data. Today, those concepts of transponders are slowly changing, and we are getting into high bandwidth communication. So today, we have 18 live communication satellites serving various users, which includes the national public sector users as well as private users. As you know, most of your digital television network information all are being beamed through the satellites that are provided by Indian Space Research Organization. So we have the user community spread across government, the public sector units, as well as private users. And one of the job of ISRO is to continually maintain this service network and make it available to users in case there are problems, maintain it, then switch over to other network, and then seamlessly maintain the service is one of the major assignment of ISRO today. The navigation and communication payload development in these type of satellites has been one of the very important, interesting journey that we had, which included the development of the first time communication satellites, Apple and InSat series in way back in 1980s. And all these were launched through procured launches. During 1990s and 2000s, the InSat 2 series got developed with the help of foreign satellite builders. In 2000, we started our own. Later time, we started develop most of the systems our own, and the contents in the satellite most of them were made in India. And we started the testing of the navigational elements in the satellites. And in 2010-20 timeframe, the regional navigation system satellites, the communication satellites with high made in India content started developing. And now we are looking at advanced high throughput satellites, high density and high throughput satellites, and also targeting to look at how to make the entire satellite building to be make in India, truly make in India. So this is the type of journey that we had in communication satellites building. Today, we can say that we are reasonably self-reliant in our communication technology, looking at the user community across the country being serviced by our satellites. And also, we have started putting it very high throughput satellites, typically going from 3.5 Gbps up to 16 Gbps type of high throughput satellites. And the attempt is to increase this data rate to serve the high bandwidth requirements of the need, which especially in cities as well as also suburbans. Now the demand is increasing, and the capacity enhancement in satellite is one of the important goals that India Space Research Organization has identified. Looking at remote sensing satellites, we see the requirement is varieties of requirement. We need to look at the land and water. We also have to sometimes look at the lower resolution, sometimes at high resolution. There is an observation requirement of the ocean, because ocean, the observations in ocean is very important for our climate as well as for various other economic activities. Also have to have observations in weather, climate related observations. So for this, various types of instruments were built over the years with the very coarse imaging capability in kilometers to sub-meter resolution. So all these images over the years have been continued being evolved, but the wide spectrum of images is one of the strengths of Indian Space Research observational platform, Earth observational platform, which you will hear in detail much later point of time in the presentations. Some of the applications of remote sensing I want to tell you today. The total satellites in service is 24. So we have one of the biggest Earth observation satellite constellation compared to many other countries. As I already mentioned, they are into various theme-based observation platform. We have the night and day visibility, imaging capability. The Bhuvan GIS platform is one of the important platform which is being served by Indian remote sensing satellite as well as other resources which is accessed by Indian Space Research Organization. Some of the applications which I want to mention today are related to the groundwater mapping, groundwater prospecting, where based on the groundwater data that has been created, suppose we start drilling for wells for groundwater exploitation, earlier success rate of almost 60% has substantially increased using this groundwater prospecting maps to almost 92%. I think this is one of the groundwater mapping, remote sensing based data creation. Similarly, various other applications in remote sensing, just to mention, is about the crop intensification, especially for the national food security missions, like the studies done in Chhattisgarh state, like we have a decision criteria to look at for further short-term crops planting, how looking at the surface wetness, temperature and rainfall, and also soil water holding capacity, a decision for short-term such additional crop can be created in this fallows. So this is one of the usage of remote sensing data. Similarly, using the images that are available from the sea, how to look at the potential fishing zones. And this work is being done using the satellite data provided by ISRO to the Indian National Center for Ocean Remote Sensing, INCOIS, which is at Hyderabad, where they provide the advisory for the fishermen in such a way that using this advisory, the fishermen need not have to roam around the sea, but to go to the abundant fish locations and saving thus the fuel and the travel time. So this is something really has been brought out economic benefits to the fishermen community. Disaster management is another important area where there is an institutional mechanism called decision support centers at national remote sensing centers is created along with the other nodal ministries and departments, where we look at various national disasters, natural disasters, especially the cyclones, floods, landslides, etc., and how to support this activity through the remote sensing area, and also conduct research and development in creating the predictive capability, observational capability, also tie up with the other institutions across the world and create the data sharing. And this is one of the important role that Indian Space Organization plays today using the remote sensing and other communication technologies. For example, in the disaster management reduction, of course, we cannot stop disaster striking. As recently, you also know the type of cyclone hit, and the casualty, as you know, today has been one of the lowest. It has already been articles that come out in talking about the casualty in the recent cyclone damage that has caused in Orissa and West Bengal area. It has been substantially reduced, though the property damage cannot be eliminated, but lives can be saved. So various data providing through the various event-based responses that we give to the departments in the area of floods and inundation measurements, forest fire, earthquake and oil spillages. We also provide the similar data to other nations also through the International Charter on Sentinel Asia. So essentially, if you look at the space program in terms of saving lives itself, I believe the purpose of the space program has been well served. Another interesting area that recently started in creating the navigation solution for us, the NavIC. It is a totally regional navigation system which serves this country and around its borders, and maybe a little far beyond that, almost 1,500 kilometers beyond that also, in providing location services, timing services, and also messaging services using the satellites. So this capability now slowly available, but it's not fully available in those devices that you can handle for this, like the mobile phones. But recently, those chips have now started coming in, and first of the telephone, mobile phones with this NavIC chip has already come. There is already vehicles equipped with the NavIC vehicle tracking devices, which is becoming one of the important direction from government to equip all the transport fleets to carry this. We also have short messaging services capability using the satellites, which is very useful for people who is going beyond our coast into the deep sea, where they will be able to communicate. There is also capability to do in distress alert terminals to service using the satellite. So these are various types of capabilities that are existing in this NavIC constellation, which is a geostationary geosynchronous satellite cluster, which is specifically serving, and we have a plan to expand it and then make it available to larger segment of the society. And this has to happen in the coming years. Bhuvan portal is something that you will hear quite often in the coming talk, so I will skip. This is one of the important geospatial portal which specifically engineered for India to serve the need. It is much far beyond the capability of typical geoportals available for the world. I think all of the teachers must explore it and make it available to those students, and then at least come across this portal once at least, so that you will continue to come to it and then understand it in the days ahead. Using the technology of communication, remote sensing, it is possible to support the governance. I think this is very, very important. How to support the governance using satellite data. And this has been one of our goals, like provide the geospatial data for supporting the land use and land cover, forestry, agriculture, drainage, infrastructure, providing the cadastral data, and also to census data to look at climate data, asset inventory for various types of assets, and looking at geotagging them, providing all this information to GeoPortal, developing the capacity building in training the manpower to handle this type of data. And this type of activities to take place across the decentralized planning system that is available in this country through the Gram Panchayat, Block Panchayat, and district Panchayat arrangements. And ISRO has been putting all the effort to make it available and disseminate through this administrative, local administration system, and making GIS as one of the important element of this governance. I think this is empowering the communities at grassroots level has been one of the important goal, and even IIRS plays this role very effectively. So we also look at societal applications in various areas. So basically we look at sustainable development, disaster reduction, and socio-economic security through the services that we do in terms of various support services. Of course, these are not done by ISRO alone. It is also done by various institutions and departments all across the country. Which some of them includes a crop production estimate, which is very, very important for a country like vast country like us to understand what's the type of crop production forecast annually, looking at various administrative actions which are required. Similarly, the water as a very important resource, looking at renewable energy, where all we can actually harness the solar energy very effectively. Potential fishing zones, I already explained. Then looking at climate and other elements like the essential climate variable, which will be useful for predicting the weather, making the models of weather predictions better. Looking at air quality measurements in various cities, providing early warning and detection, as I have already mentioned. So all of these are essentially the societal application that comes out of the satellites. So we have been organizing projects across departments, and this is very, very important. When Prime Minister in 2015 called all of us, all the departments, along with ISRO, and then wanted us to prepare the departments of this country to make use of space technology for at least one of their program. And it has been a successful journey ever since that directive. And a lot of departments of the government of India has come forward to work with us and then develop space-based capabilities in all the departments. And many of them probably you may hear in the coming days. Let me go to some of the area where I have been personally working, contributing, is the launch vehicles, which is called the Space Transportation System. The journey for Space Transportation System has been of the true Alpanirbharata, which is basically the indigenous capability development in building the rocket systems for ourselves. And technology for rocket is not just easily coming by. It has been a tough journey in starting from 1960s, the sounding rockets, where it was brought from US and Russia and launched from Tumba. Then Abdul Kalam, as a project director, developed the first of the launch vehicle, the SLV-3 in 1980 timeframe, which was having capability to put only a 40-kilogram satellite. Today we have 4,200-kilogram satellites being launched in the GSLV Mark III, where I had the opportunity to direct that project during its first of development. Today we are looking at various future missions on enhancing this capability so that all our satellites will be launched from our own soil. And this has been the goal. It is not to compete with anybody, but really to create a technological capability within this country itself to have the launch vehicle building, designing, whichever size we want. Even if you want to build a 10-ton to GTO capability, we definitely have the capability to build. But of course, we need to decide programmatically what is needed and what is not needed, looking at the resources that we have at any point of time to spare. And this is what limits us only today. The technology for launch vehicle development is really multidisciplinary, and probably the core of the engineering in various disciplines comes into it, like the aerodynamics, the various propulsion systems, the control design, host of materials that goes into building the rockets, the manufacturing technologies, non-metallic like chemicals, propellants, the quality systems, the testing and activities, modeling and simulations. All the research activities has been done across the centers in launch vehicle community, and capability has been developed today to build any rocket that we want. I think this is something we must be really proud of. The PSLV is at the top today. It has done almost 50 plus flights, having customers across the country, having varieties of missions that it has accomplished, including the Mars orbiter mission, the Chandrayaan-1, and it is one of the most reliable and sought after launch vehicle. At least for the next 10 launches of PSLV are fully booked, I think, with our own satellite as well as commercial satellites. And finding a slot in PSLV today, it's one of the difficult things. And our challenge today is to manufacture PSLV in more numbers and make it available to more and more users. And this is something that we are working on. The versatility of PSLV has been so immense that it has been able to carry and accommodate satellites of various kinds in various forms in single missions, as well as even up to 104 satellites we could do in one mission. And also complex missions we have performed to meet the needs of the users. GSLV is a very successful launcher, though it has faced so much of difficulty in the early phase. Failures were there, but all those failures were now overcome, and we had 5 successively successful missions, and it has established its reliability and is poised for various special missions. This is something very special launch vehicle, having almost double the capacity of PSLV, but it is mostly used for geosynchronous missions and remote sensing missions of very high capacity. GSLV Mark III is the future launch vehicle, which has a high capacity, with the first launch being the CARE mission, the human space capsule recovery is what we demonstrated in the first mission. But the subsequent missions done the Chandrayaan-2, and is now poised for the Gaganyaan launch. And this vehicle is going to be human rated to do the human space flight mission. The GSLV Mark III M1 mission, in its first operational flight, launched the Chandrayaan-2, which has taken a GTO payload almost 4 tons to the orbit, and then later it moved towards the moon and then had the orbital mission as well as lander demonstration. The capability to build launch vehicle is fundamentally depends on the propulsion capability. So I'm not going to the every area of technology of launch vehicles, but just to show you that we have solid propulsion capability, which is very wide varieties of solid motors. For example, one end we have solid rockets, which can, which is called S200, has 200 tons of propellant in a single motor, 200,000 kilogram. Whereas on the other end, we have a small motors, solid motors, which has only a few grams of propellant. So varieties of solid motors it is possible to create in centers like Vikrant Sarabhai Space Center and Satish Dhawan Space Center. We are able to manufacture. Same is the case with the liquid engines. This is done in Liquid Propulsion System Center as well as ISRO Propulsion Complex at Mahendragiri, where we build the engines as well as the stages and conduct the test on these engines and then qualify them for induction. This includes the air-storable engine, cryogenic engines, satellite engines, and control thrusters, electrical propulsion systems. All these are done by these centers. So this capability is also developed. It's not fully developed in-house, but we had certain level of acquisition of technology from Europe. We had acquisition from Russia, Ukraine, and we continue those technology development ourselves until we developed our first fully indigenous cryogenic engine, the C25 engine for GSLV Mark III, 100% within ISRO. And we were successful in all the missions with that engine. Currently, we are working on a small satellite launch vehicle, SSLV, which is a very small satellite launch vehicle, which will be useful for serving the commercial launch market of for the satellites. Typically, now there are a lot of small satellites coming up for low orbit communication and how to serve them with short duration launch capability. And that is what is being served by SSLV. We are planning to have its inaugural launch this year itself. And because of the pandemic, we had to have some setbacks, and we will be coming back very soon to make it operational. Probably this will be happening as an operational launch vehicle in the private industry's hands. We are also working on reusable rocket. Reusable rockets are very, very important rockets. You know, some of you may be knowing the space shuttle was one of the very successful reusable rocket. But further, Americans are still trying to develop the space plane X series of flights. We also continue to develop our reusable rocket. And one of the mission we had of sending the reusable rocket to flight and then land in sea, but we are taking it further in developing further capabilities. I will just show you another slide where we are currently working on this reusable rocket. We are trying to do a landing experiment using a helicopter, and then later put it on a rocket, take it to orbit, and then do some satellite deployment or do some orbital science experiment and come back and land in India itself. So this project is what we are currently going on. and we are hopeful of completing this another 1 or 2 years of time frame. Another interesting work which we are currently doing is to enable air breathing engines. All of you know rocket contains fuel in the form of kerosene and oxygen oxidized in the form of sometimes liquid oxygen. But if you use a engine called scramjet engine, we can take the oxygen from the atmosphere and then burn the kerosene and produce a thrust. By we can reduce the mass of the rocket substantially. So this work we started some time back, and we have successful in developing a small engine. Now we are working on a bigger engine and then test it as a flying platform for demonstrating hypersonic flight. Hypersonic flight is typically flying at Mach 6 times the speed of sound. So if you want to travel 1,000 kilometers, it will be only a matter of few minutes. So such a vehicle we are trying to develop and then demonstrate today. We have an array of rockets currently under development. You can see that the first of the three are the ones which are already developed, but the remaining ones are currently in the process of various stages of development, including the human space flight mission. While we work on rockets, very important thing is to develop the infrastructure for manufacturing rocket as well as launching them. The launch complex, the Satish Dhawan Space Center, is an island where we have created the infrastructure for making solid motors, processing rockets, as well as launching them, controlling them. So we have the launch complex at first launch pad, second launch pad, where we operate and build those rocket elements and then launch them. So this capability we have developed there. We are also further augmenting this capability so that as a declared capability, something like 20 plus missions we will be able to launch in every year. And this capability is now currently under construction. And if in some short time, I am sure this will come to an operational level. Let me speak a few words about the Gaganyaan program, which is a very interesting program. I think all of you might have read about it. The human space flight program, where we want to send 3 astronauts for 7 days in space. This is our goal right now, declared goal. What we don't know till now is we know very well how to build rocket, how to build satellites. But if you want to take human beings on space, then we need to have capability to life support system. They need to breathe. They have to survive the temperature. They have to survive the acceleration. They have to survive the loads created by the rocket, and then have the food and all other infrastructure on board. And so we need to have work on human science and bioastronautics capability. We must develop the human machine interaction should be developed, and all these are currently going on in developing the crew module, the habitat of the Gaganyaan, as well as the service module to keep its orbital healthy, and then finally come back. And this capability currently we are working on. So it is a new domain what ISRO has now embarked on, where we'll be launching the Gaganyaan using the GSLV Mark III rocket. They will go to orbit. In the orbit, it will spend some time and carry out certain experiments. And once the mission has been accomplished, it will separate out from the service module. The crew module will enter the atmosphere and with intense heat, which is protection system, come back to the denser part of the atmosphere, where it will deploy the parachutes and then land in the sea, and which will be recovered using ship. So this is a overall plan. The entire mission plan has been done. Currently, the ISRO centers are working on various elements of this mission. And we will be going for an unmanned mission where no astronaut will fly. 2 such unmanned missions will be done and followed by the human flying and incorporated mission will happen soon. It is not enough that we do this mission, but we also have to look at how we take forward this. So taking this human space flight program in a sustained manner for building space infrastructure, long-term stay in orbit, creating a space in habitat, etc., is one of the goals. But we have not made a very clear definition of what exactly is going to happen. But at least for us, it is very clear in our minds. It is not just sending the first human being space is not the only goal, but to create this capability as a sustained capability for further exploration is definitely the goal of ISRO and all the mankind. Let me look at some of the interesting missions for exploration and space science as well. Some of the missions that probably you are already aware of are Chandrayaan 1, Chandrayaan 2, AstroSat, and Mars orbital mission. Chandrayaan 3 and Aditya L1 are the one which are yet to happen. And Chandrayaan 1 was very hugely successful mission where we sent Chandrayaan 1 through as an orbiter around the moon, and also we had a moon impact probe. This is a mission which identified the traces of water on the lunar surface. And Chandrayaan-2 was attempted to with the orbiter and lander, but the orbiter had a successful orbital mission, whereas the lander made almost a landing demonstration, which we had missed the last of the leg, which will be definitely will be achieved using Chandrayaan-3 mission, where we'll be sending an orbiter and a lander once again. AstroSat is an interesting mission, which is the first time observatory, which is looking at multi-wavelength observations in a single satellite. This is the first time such a satellite is being launched, and we have a lot of events observed using AstroSat. Mars orbital mission is the very interesting mission where we have launched it to the first time launch successful mission. Aditya L1 is another mission where we will be launching to study the corona, chromosphere and photosphere of Sun using special observational elements, and the satellite will be placed at the Lagrangian point L1. Of course, some quick facts about it. See, today in ISRO, we have so much of research activities in space physics. Across the space physics groups in ISRO, we have one at PRL, another at VSSC, another at IIRS, and across various centers, we have physics groups which looks at both Earth and atmosphere as well as planetary space science activities. So a lot of research work is happening through ground-based observations as well as space-based observations. So that is one very, very important area which ISRO is working, and they are also these groups are developing instruments which will fly into some of those missions in the future. Chandrayaan-1 mission, all of you know that I have already explained that it is the one mission which detected the hydroxyl elements and water molecules in lunar surface, and we have been awarded by the International Academy of Astronautics for the team achievement in Chandrayaan-1. And for this, we have developed various facilities, including the deep space network at Bailalu. So the Mangalyaan is another very, very challenging mission, having a 300 days of travel, reach up to this red planet, and then successfully injecting the satellite into the orbit. And I want to tell you, this mission has been such a successful mission that it went to the orbit for 6 months life and still working. I think this is something that we must all be proud of. We have very good scientific objectives met by this mission, and a lot of publications have come out of this research work into the Mars orbital mission. So I'm not going to the various outcome of this mission, which has been now open to the global scientific community for proposing various additional studies that can come out of these missions. And one of the important achievement has been the atlas that has been published for the Mars, first time using the images from Mars orbital mission. Chandrayaan-2 is a satellite that we built with great expectations in having an orbiter and a lander. You can see the orbiter and lander being integrated into the payload fairing of GSLV Mark III, and the first of its operational mission accomplished the successful insertion of the Chandrayaan-2 in orbit. But of course, the lander had a narrow miss while it was trying to land due to a glitch. Of course, that this will be overcome in the coming mission. I am very sure about it. The engineers and scientists at various centers are working very, very hard to understand what went wrong and then correct it. And in the coming missions, you will all be with us to support and pray for us to while we accomplish the next of Chandrayaan-3 mission in the through GSLV Mark III to insert into a 170 by 186,000 kilometer, and then later circularize and land it on the orbit of Moon, on the surface of Moon. It is not the exploration of Moon and Mars that we have identified. ISRO has been looking at various exploration ways to look at the solar system, and a vision document towards solar exploration, solar system exploration, looking at other planets has been made, and this becomes the baseline on which further work on various missions like going to Venus and other space objects exploration are being worked out. I believe this study will be continuously updated in the coming days to look at what all we can do with our capability in launch vehicles and satellites to look at the plane in the orbit of the solar system to find out something that others have not done. I think this is very, very important. One of the important work that we did, the AstroSat, I already mentioned, so I will skip this. In the space science area, we have done the Chandrayaan-1, the Mars orbital mission, the AstroSat, Chandrayaan-2. The future thing are ExpoSat, Mars orbital mission 2. There is a study going on Venus mission, lunar polar exploration, which is along with the Japan, JAXA, and also the exoworlds, looking at the exosolar planets. So these are some of the space science experiments or missions that are currently being conceived. We also have joint missions with other nations, like the Chandrayaan-1 had a international payloads. Megatropics is an Indo-French satellite where we looked at the various tropical studies using the French collaboration. SAREL is again Indo-French satellite for oceanographic studies for global users. NISA is a satellite where India and NASA were jointly developing the dual frequency synthetic aperture radar for Earth's observation, which is currently being scheduled. Trishna is again an Indo-French satellite, look at thermal infrared imaging. Similarly, the JAXA ISRO mission to look at the lunar mission for lunar polar mission. So science mission and collaboration with other nations is one of the important element of our exploration strategy. We also look at opportunity for teachers like you, students like you to come to conduct experiments on board PSLV. If you have a very interesting experiment that you can conceive in laboratories within India, we can host it on PSLV and then send it to orbit, provide you with the data, and then do certain experiments. So we have developed a orbital platform on PSLV to support low-cost experimentation, tinkering labs as we call. We would like you to make a note of it. If you really are interested to develop some payloads, low-cost payloads, along with the universities, colleges, schools, we can host you. We can help you in building it also. So please contact the concerned nearest space agency how to derive support out of ISRO in doing such experiments. Let me quickly go through some of the future activities of ISRO. I have mentioned today that we have done rockets, quite a large number, satellites. We have established a lot of capability. We have established science exploration capability. What is next? So how is the ISRO going to be in the future? I think this is very, very interesting. What we have looked at is the space activities. So the space business all across the globe is a $360 billion business. Substantial market is there for satellite data and processing, whereas the launch vehicles community is a very small business. Satellite industry is a huge business area, and we have not explored much of this market, and we continue to remain a very small operator as far as the global space business is concerned. So this is one observation that we have today after going through a 50 years of journey in ISRO. Today, our annual budget is typically of this order, something like 14,000 crores with almost 20,000, 18,000, 20,000 manpower. This has become all reasonably a stable arrangement. And if you look at this business opportunity, provides you certain number of launch vehicles, certain number of satellites that can be launched, and certain number of missions that we can accomplish. But this is not what we want. We want to take it further. We want to have a significant space business and space activities in this country through various stakeholders. And this is a goal that government recently told, that we need to diversify and look at way by which industries, startups, research establishment are becoming co-travelers in the space program. So ISRO, as a space technology provider, a space research provider, we will have another agency called InSpace, which will look at a regulator and authorizing agency for all these new players to come in, like industries to come in and then take up space activities. We will also provide them to enable handhold with the ISRO, identify and opportunities that they can work on. We can authorize the launch. And there is another agency called NSIL, New Space India Limited, which is a public sector undertaking, which will work towards creating funds and business, and also production of these activities across industries. So this type of new verticals that is coming into ISRO is really going to significantly change the way we work. Like such as one example which I want to give is, look at the operational launch vehicles, which will, like the PSLV, GSLV, Mark, etc., which are medium and small rockets. SSLV will be commercially realized through industries, whereas future developments like the Heavy Super Heavy Limited could be developed through ISRO or joint development. But there are various technology developments like the air-breathing engines, reusable rockets, etc., will continue to be supported and developed by ISRO through government funding, whereas major work of launching will be handled by these commercial operations through realizing these rockets through industries, both satellites and launch vehicles. We will continue to develop advanced rockets like heavy lift launch vehicles, reusable rockets, and also advanced satellites like all electric propulsion satellites, 6K bus, which is typically going to be the high throughput communication satellite buses, etc. We also want to look at building the satellites with more and more indigenous content, including the various RF elements meant for the satellites. All these are some of the goals that we have set for in the future. In the space industry side, a lot of changes are going to happen. Making India is always have been the goal of the government, and in which the space technology also has to move in, where we'll be handing over the building the satellites and launch vehicles to this industrial establishments, and new technology areas are going to come up, including startups and big industries. We have to look at how this whole activity can become profit-making industry. We have not been looking at it like this till now. And throughout the history, ISRO has been a fully funded and a government-sponsored activity. I think it can no longer work in that same mode. It has to become a business, activity which will produce a substantial outcome and profit out of the whole activity. And it has to become really commercial, of course, supported by government in various ways. So this is the change which is going to happen. Another interesting change which is happening is the startups that are coming into this area. Almost 160 startups with good funding has come in building launch vehicle business. Almost three small companies are building rockets today, and I'm really happy to tell you that those small industries or startups are successful in making their engine, and some of them have already tested them. They are now in the hardware production time and going to get into launch pad maybe 1 or 2 years of time from now. So similarly, in the satellite area also, there have been some startups who are trying to build the satellite capacity, created the infrastructure now. In the data and application side, there are many more companies who are looking at how the satellite data processing and making it available in a commercial basis can be a really rewarding activity for private entrepreneurs. I think this is another interesting activity happening all across this country in the area of startups. So we have in ISRO, we have set up a big vision to 2030 in terms of creating launch vehicle capability to up to super heavy satellites. We also have looked at how to build our new infrastructure in terms of satellites. For example, creating low Earth orbit constellations, global navigation systems, quantum communication, which has been recently down demonstration, creating human capability, flight capability, building up to human habitats, carrying out robotic missions, maybe having a human space flight to Moon and Mars, looking at exoplanets, doing asteroid flyby and sample return missions and deep space missions. I think all these are something we are just now talking, but creating step-by-step capability within the limited resources that we are able to identify from this country. I think it is our destiny and desire to work on all of them in a continued manner, making incremental progress over the years. And it has to also be done with the association of all those partners with us, such as industries and academics, while creating this capability all across the country, not only within ISRO. So the space program way forward will be something that will grow in terms of business volume from current 13,500 crores to something like 50,000 crores. I believe so. Production will be such as some 10s to some maybe 30s and 40 launches in a year, including satellites building. And in technology side, instead of having the technology fully concentrated in ISRO, it will be a collaborative technology sharing where the industries and academia will be partners in developing the technology and then feeding into this area in a bigger way than what it has been doing so. So we also should realize that across the world that there are disruptive technologies happening in the launch vehicle and satellite area, and it is important that we keep tag on each of them and then contribute specifically in each of the areas so that we will be able to become a strong space power and also a technology savvy country where space technology will become one of the strong arm of this nation to create observational capability in various domains, including national security and national resources planning, which two are very, very important arms of the country in addition to the governance. So with this, let me say big thanks to you, teachers, teachers, I think you are handling the future of India, the young generation. I tell you that you should be an inspiration to them. You inspire them to follow their passion and mold them to take up the nation building. Make them technology warriors to provide leadership for Bharat. I think this is your destiny and this is your role. I want to tell you that it's very important that as teachers, you need to identify the creativity in students and not simply mugging up people, but who have the talent to become different. I think you spot them and nurture them. I think through them, we create great scientists, great nation builders. Thank you so much. And for the time that you have spent here listening to me and speaking about ISRO. Once again, thank you.